So we are now on to our third out of 4 conic section shapes. This is called an ellipse. It's basically like an oval. So an ellipse and an oval, essentially the same thing. The ellipse is just the more math sort of word. So we've got these pictures that look absolutely insane. And the definition of an ellipse is absolutely insane. Has to do with these 2 points right here. We've got, this is a focus, that F, this is a focus, focus, focus. These 2 points, it comes from this formula where every point around the ellipse, the sum of the distance of the points from the 2 focuses are the same. Like, the definition is absolutely crazy. So here's what I want you guys to remember, because the definition is great, but you don't ever have to memorize it. You don't need to know what the definition is in order to have to actually graph these ellipses. The important part is this. So you know with a circle, in 9-3, you started with the center, and then you went the certain number of units, the radius, whatever that was, you went the same number of units left, right, up, and down. And that's what made it a circle, because all the points were equidistant. With an ellipse, what I want you to remember is there's going to be 2 different values that sort of act like the radius. So they have a center right here, just like the circle does. So notice that's the center, that's the center. And then instead of going the same number of units in all 4 directions, there's one number of units that you go left and right. So see how there's an A labeled right here? So you go A units left, A units right. And then here you go, right or left, right. And then you go a different number of units up and down. That's the important part. And this page is kind of blank. There's not really a lot that we're going to end up writing here. I just wanted you guys to see those pictures. So technically an ellipse could be a horizontal ellipse or a vertical ellipse. The only difference between horizontal and vertical is that you go farther in one direction. So we technically classify this one as being a horizontal ellipse just because it goes farther left and right than it does up and down. And we technically classify this one as being a vertical ellipse. But essentially, the shape's the same, the formulas are going to be the same. So let's take a look, speaking of formulas, at the formula that we have here. So it's actually really, really similar to the formula for a circle. Notice we've got an x squared term plus a y squared term. The difference is that you've got a 1 on this side, and then you have these different denominators. Okay, so the denominators, that's what's going to tell you how far left and right you're going to go. Okay, so this one, notice this is just an x and just a y. Just like with the circle, if it's just x and y, then the center is going to be 0, 0, right at the origin. And then the length of the major axis and minor axis. Okay, so those are those 2 different things that you have right here. So you've got the major axis is the longer of the 2. The minor axis is the shorter of the 2. So I don't want you to think of it as being a major axis and a minor axis. I actually want to make a brief change to this. So let's say the length of the left and right axis, and then the length of the up and down axis. Because if you change, like sometimes the major axis would be the left and right one, but sometimes the major axis would be up and down. So the length of the left and right axis, x, tells us how far left and right we're going to go. So we would start at the center and we would go left A units and right A units. So all the way across, it's going to be 2 A units. Okay, so from the center, you're going to the left A units and you're going to the right A units. Again, from the center. So altogether, that would be 2 A units. And then y, since y is vertical, y tells you how far up and down you go. So we're going to go B units, whatever B is, up and down. So altogether, that axis would be 2 B units. You're going to go up B units, and then you're going to go down B units. Okay, so that'll be more helpful when we're graphing. You'll see once we start to combine these into equations. And then the vertices, that's going to be the top and bottom points, kind of the edges. All right, so instead of vertices, let's change this to the left and right edges, and then the up and down edges, the far edges of those ellipses. Okay, so left and right, you're starting at the center and you're going A units left and A units right. So the 2 vertices, it's going to be A units left, but you haven't gone up and down yet, and then A units right, and you haven't gone up and down yet. And then up and down, your x value is still 0 and you can go down B units, or your x value is still 0 and you can go up B units. So those are going to be the vertices. And you can see with example 1, we've got these vertices and co-vertices. Again, the name vertices and co-vertices, those just come from which one is longer. And it doesn't really matter to us which one is the longer of the two. So the vertices are always the longer. Notice 5 is bigger than 3, and the co-vertices are shorter. So our vertices are 5 and -5. Those are y values. That means you're going up and down 5 units. So when you go up and down 5 units, that means that B is 5. And then your co-vertices, you're going left and right 3 units. So that means that A is 3. Okay, and then since this is a 0 and this is a 0, we're centered at the origin. So all we're doing is we're taking A and B and we're just going to plug it into this equation right here. So x squared over and then plus y squared over equals 1. This is kind of the skeleton form for our equation. The plain old x and the plain old y tell us that we're centered at the origin. And then under the x, how many units do we go left and right? We go 3 units left and right. So 3 squared is 9. And then under the y, how many units do we go up and down? We go up and down 5 units, and 5 squared is 25. So that would be our equation. Okay, so that's if you're centered at the origin. We're not always going to be centered at the origin, so here's a look at one that can be translated. So remember the h and the k, we saw that when we were dealing with circles. So all it does is it moves our center to be at h comma k. Okay, so now we're going to change these values again. Okay, so the length of the major axis, instead of major, we're going to do a left-right axis and an up-down axis. Okay, so let's start with that. So the major axis is still going to be, the left-right axis is going to be 2a. You're going a units left and right from the center, and then you go b units up and down from the center. Okay, so x is associated with left and right. We're going a units left and right. Y is associated with up and down. We're going b units up and down. Okay, and then the vertices, again, we're not going to call them. They're still called the vertices and the co-vertices, but we're just going to make kind of an easier note here. So the left and right edges of the graph, and then the up and down edges of the graph. Okay, so the left and right edges, this is where things get a little bit tricky, because notice you are centered at h comma k. So from h, you're going to go left and right a units. So we start at h, and then we go either left or right a units, and our y value is not changing. So those are the farthest edges to the left and to the right. And then up and down, our x value is still h, and then we're starting at k and then going up or down b units. Okay, so let me give you just a quick sketch just so you see what on earth I'm talking about here. So could be centered anywhere you want. This is the center. This is h comma k. And then we're going a units left and right. So if I go a units to the right, a units to the left, this is whatever h was plus a, but then the y value doesn't change. This is whatever h was minus a, and then the y value doesn't change. And then we go up and down b units, whatever b is. So here h isn't changing, but k is increasing by b, And then here, h isn't changing, but k is decreasing by b. So that's what I mean when I talk about the left and right edges and the up and down edges, or top and bottom. Okay, so let's look at this example right here. So write an equation for the ellipse with vertices, co-vertices. So here's the easiest way to do it. We're just going to plot it. We're going to plot those 4 points. From there, we should be able to figure out the center, and then how many units left and right, how many units up and down. Okay, so set up a little coordinate system. We're going to plot. So -6, -2. Okay, so here's one edge right there. 4, -2. So that'd be right there. -1, -4 would be right there. And -1, 0 would be right here. Okay, so that's our ellipse. So go ahead and sketch that in. So this is the ellipse that we're supposed to be coming up with an equation for. Ooh, that was terrible. So we should be able to come up with the center, and then A and B. So the center is actually pretty easy. You just trace these together, and then where they intersect, that's the center. So this is our center right here. So let's write that. Kind of calculate it out and write it down. So our center, h comma k, if we just figure it out, so the x value is -1. Notice that the x value of the center is the same as these x values, and these x values are -1. So the x value of the center is -1. And then the value of k is the same as these y values right here. And these are both at -2. So you can see from these points. So there's -2. So that's h and k. So that's going to go into our formula. So let's start it off. So h minus -1 squared over something plus y minus -2 squared over something equals 1. So we know that much so far. We know the center. And then for A and B, we're going to count how many units left and right, how many units up and down. So for A, how many units left and right from the center? Well, I can count 1, 2, 3, 4, 5 to the right, and then it should be the same to the left. 1, 2, 3, 4, 5 to the left. So A is 5. And then B is how many units up and down. So from here I go up 1, 2, and from the center I go down 1, 2. So B is 2. So all that's left to do is just plug them into the equation. This should be an A squared. So 5 squared is 25. And this should be a B squared. 2 squared is 4. So that is our equation.